Hello viewers and welcome to the lesson. In this lesson I want us to solve a question on area approximation. We shall use a question in 2008 KCSE paper 1. So the question is here. The figure below is a sketch of the curve whose equation is given by y is equals to x squared plus x plus 5. It casts the lines y is equals to 11 at points P and Q. So that is the curve, you can see it. Then the line y is equals to 11 is there. The limit from -3 all the way to 2. Here are the questions. A. Find the area bounded by the curve y is equals to x squared plus x plus 5, something y is missing there, and the line y is equals to 11 using the trapezium rule with 5 strips. Find the area bounded by the curve y is equals to x squared plus x plus 5, and the line y is equals to 11 using the trapezium rule with 5 strips. Now, which is that area that is bounded by the curve and also this line y is equals to 11? The area is here. I'm going to shade that area. So the area that you're required to find is this area that is here. That is the area. So that is the area that you are required to find. That is the area bounded by the line y is equals to 11 and the curve y is equals to x squared plus x plus 5. Now, to get that area, there are two things that you need to do. You need to get the area under this line y is equals to 11 between -3 and 2. Then you subtract the area under the curve between x is equals to -3 and x is equals to 2. I repeat that again. To get the shaded area, that is the area bounded by the curve y is equals to x squared plus x plus 5 and the line y is equals to 11, we shall need to find the area under the line y is equals to 11 between x is equals to -3 and x is equals to 2. Then we subtract the area under the curve between x is equals to -3 and x is equals to 2. That is what will give us the area bounded by that line and the curve. Now, to do that, I'll have to prepare a table. I've prepared a table here all the way. So you shall have some points here you have to insert. So from 0 you have -1, then you shall have, this is -1 and then -2, and then here between 0 and 1 you have 1. So the 5 strips, these are how you get the 5 strips. So these are how you get the 5 strips. So you can see now these are the 5 strips. So you have one strip between -3 to -2, the other strip from -2 to -1, -1 to 0, 0 to 1, and 1 to 2. So these are 5 strips. 1, 2, 3, 4, 5. So I will prepare a table of values. These I will use this function to fill this table from -3 all the way to 2. So in this you just need to use a calculator. So I'll go very fast here. I just need to substitute when x is equals to -3, substitute in that function and get the corresponding value. So when x is -3, I'll just do that one very fast. You substitute x is -3 here using a calculator. You get this one as 11. This will give 11. That will give 11. Then when x is -2, that will give 7. Then when x is -1, you get 5. When x is 0, you get 5. When x is 1, you get 7. And then when x is 2, you get 11. It's just a matter of substituting the x values in that function and get the value of y. And after doing that, now we're required to use the trapezium rule to calculate the area under the curve. This will give the area under the curve. It will not give the required area bounded by the curve and the line. So this will give the area under the curve. I have to indicate it here. It will give the area under the curve, and that is what you're going to use the trapezium rule. The trapezium rule states this area is given by half height, then you have y0 plus y n plus 2. Let me, for the purposes of this question, I'll just let me just use y0. So y0 will be here, then y1 will be here, just indicate, then y2 will be there, y3, y4, y5. So have height, then y0 plus y. Let me use the first and the last. These will be y5. Then twice the middles. The middles are y1 plus y2 plus y3 plus y4, and then the square brackets. So I've just let these heights to be 11 to be y0, then y1, y2, y3, y4, y5, and so on. So substituting these are you're going to get. So I have height is the width of each strip. The width of each strip is 1, -3 to -2, that is 1. It is uniform. So half times 1 is just a half. And then you have the first and the last. The first height is 11, that is y0. Then y5 is 11 again, plus twice the middles. The middles are 7. The sum of the middles, 7 plus 5 plus 5 plus 7, like that. So these are to give, and these are to give, or have the square brackets here. 11 plus 11, you get 22. Then plus twice, this will be 12 times 12 plus 12, this will be 24 times 24, like that. So this will give a half multiply by 22 plus 48. This will be 22 plus 48. This will give 70. And when you work out the half of 70, will give 35 square units. So get 35 square units. That is the area under the curve between x is equals to -3 and x is equals to 2. Now, for us to get now the shaded area, we need to get the area under the line. The area under the line between x is equals to 3 and x is equals to 2. Now, when you look at this region here, you notice that this one is a rectangle. The area under the line between -3 and 2, that forms a rectangle. P, from where we have P to -3, then to 2, and to Q. That is a rectangle. And this rectangle measures from -3 to 2, those are 5 units. From -3 to 2, these are 5 units. Then upwards, you can see where this line is, y is equals to 11. So this point here, the y value from 0 to 11. So the length would be 11, and then the width will be 5. Hope you can see that, because you can see this line cuts the y-axis at y is equals to 11. So this vertical displacement is 11. So this one is a rectangle measuring 11 by 5. So for that one, you don't need to use trapezium rule. We just get the entire area using just the basic formula of calculating the area of a rectangle. So the area under that line, y is equals to 11 between -3 and 2, that will be the area of the rectangle measuring 11 by 5. So let me indicate that here. So area under the line, so area under line, y is equals to 11 between x is equals to -3 and x is equals to 2 will be the area of the rectangle. The area of the rectangle, and that rectangle of seen it measures 11 by 5. 11 by 5. 11 by 5, and that will give 55 square units. 55 square units. Now that we have the area under the curve and the area under the line, to get the area bounded by the curve and that line, we shall get the area under the line the area under the line. So now we are getting the area under, not me just read these, the area bounded by, I don't need to write these, the area bounded by the lines, line y is equals to 11, and the curve will be the area under the line, which is a 55 square unit. Then we subtract the area under the curve. The area under the curve y is equals to x squared plus x plus 5, which you got as 35. We got that one as 35. And when you subtract these will give 20 square units. That is the area. So this area therefore is 20 square units. So that is how we work out that area. Now we can proceed to the next question. The next question is here, and this question is B. Calculate the difference in the area if the mid-ordinate rule with 5 ordinates was used instead of the trapezium rule. The difference in the area if the mid-ordinate rule was used with 5 ordinates. So let us first calculate that area, the same area using the mid-ordinate rule. Using the mid-ordinate rule with 5. This one is with 5 ordinates. With 5 ordinates. So how do we get 5 ordinates? Remember, using the mid-ordinate rule, we use the mid of each strip. So we shall have the center of that strip there. We shall use that. Then we have the center there. The center of this strip. This is the ordinate that you require. Then that strip again. So all these 5 strips, we get the mid or the center. 1, 2, 3, 4, 5. So this one will have this will be y1, this ordinate 2, y2, y3, y4, and y5. So the first mid-ordinate of the first strip will be y1, the second mid-ordinate will be y2, the third mid-ordinate will be y3, the other mid-ordinate y4 and y5. So the center of each strip, it will give 5. So I'll need to prepare another table now using the mid-ordinate. You can see the first one is between, this will be 2.5, between -3 and -2 will be -2.5. The other one is -1.5. The other one is -0.5. The other mid-ordinate is between 0 and 1, 0.5, and the other one is 1.5. So that is what I need to have. So I'll have -2.5. Then the other one is -1.5. So -1.5. Then from -1.5 I will have -0.5. Then from there 0.5, then 1.5. 1.5 is the last one, so they should be 5. So 1, 2, 3, 4, 5. So those are the mid ordinates. I've just extracted them from here. So this is this will give y1, this will be y2, y3, y4, and y5. Those are 5 ordinates. So the same thing we did to the first part, we shall now fill this table, the values of y, using the function y is equals to x squared plus x plus 5, just feeding the values of x in the formula and then the function, and then getting the corresponding values of for y. So when x is -2.5, we need to put this on very well using the bracket. Let me just demonstrate the first one, y. For example, these are supposed to put the brackets when x is -2.5. So this would be -2.5 squared. That is how we're supposed to feed it. Then plus -2.5 plus 5. So that is how you're supposed to carry out the substitution, by putting the brackets like that, especially when you have negatives, to avoid confusion. So when x is -2.5, just feed it in that function and you're going to fill. So I've filled this one, so let me do it very fast. So like the first one, you get 8.75. The second one is 5.75. The third one is 4.75. The other one is 5.75. And then the last one is 8.75. So those are the ordinates that you get. Now using the mid-ordinate rule, mid-ordinate rule is given by, and you have these values to get the area by mid-ordinate rule. You get it will be the height multiplied by the sum of the ordinates. This is how we use the mid-ordinate rule. Now in this case you have the height, the sum of the ordinates are y1 plus y2 plus y3 plus y4 plus y5. So the height of each strip that we obtain the mid-ordinate, this is the height of this strip is still 1. The first strip where we have the y1, it will be 1. So the height is, we take the height of each strip, so that is the height of this strip, that will be 1. So 1, then 8.75 plus 5.75 plus 4.75 plus 5.75 plus 8.75. 1, 2, 3, 4, 5. So when you add all these and then you multiply by 1, 8.75, you add everything. I've already done that. When you add it, when you add everything, you get 33.75 square units. You get 33.75 square units. That is the area under the curve. Need to get these. It is the area under the curve using the mid-ordinate rule, but it is not the area bounded by the line y is equals to 11 and the curve. So again, to get that area, we need to take the area of the rectangle. Again, we got it as 55, and then we subtract the area under the curve using mid-ordinate rule, which is 33.75. 33.75, and this one will give 21.25 square units. So this is the area, the same area bounded by the line y is equals to 11 and that curve using the mid-ordinate rule. So the question was, what is the difference in the area if the mid-ordinate rule was used instead of the trapezium rule? So you just need to get the difference. So what is the answer? When we use the trapezium rule, we got the answer is when you used it, we got the answer is what? Let me see. We got the answer is 20. Yeah, we got the answer is 20. But when we used the mid-ordinate rule, we got the answer is 21. So the difference is, the difference 21.25. That is when you use the mid-ordinate rule. Then using the trapezium rule, we got the answer is 20. We got the answer is 20. So we get the difference, and this difference is a difference of 1.25. That is the difference, and that is simply how you're supposed to solve that question.